Um, but you're in downtown, are you, Jeff? Where are you at, downtown? And Chris, are you?
Yes, I'm near north, I guess you'd call it.
So
1300 north.
if you want to write Chris's name down, and then Chris, do you mind if he looks up your name and asks you about the process of getting a an ODU, because we need to get that happening for Jeff real soon. We got
Sure.
Bolton weather's coming up right quick here. All
Sure.
right, I show 7 o'clock, and with that, thank you everyone for being here tonight. Chaz, tell us about bad weather.
Okay, do I have this? Yeah, do I have the screen?
You should be co-host. Yep.
Okay, and let's see, one more click. Full screen. All right, can everybody see the notice of copyright?
Yes.
Okay, all righty. First off, let me start by saying that this is the fun chapter. If damage and destruction and so forth can be described as fun, but this is the one where exciting things happen in weather, and it's to my mind, the most interesting chapter in this entire class. And I am very grateful to Bob for giving me the opportunity to teach it, because it is the most engaging to me. And what it is chapter 6, severe weather. So first off, we're going to talk about thunderstorms, lightning, and hail. The thunderstorms in general, what they are: small ones, medium-sized ones, big ones, lightning and thunder and what it can do, and mentioning hail. Then we're going to move on to tornadoes and hurricanes. So all the fun stuff. Okay, thunderstorms. A thunderstorm is a mesoscale convective system. You remember what that means. Mesoscale is comparatively small as compared to worldwide weather bands and highs and lows. Convective, because we've got air moving up and down in columns, and a system. So there's a wide range of severity. Little tiny thunderstorms that just pop and crackle a couple of times, up to mesocyclones and squall lines. Most thunderstorms are mild. They only last 20 minutes or so. But 10% are severe thunderstorms. A very distinct definition of a severe thunderstorm. Remember this, you're going to see it. Winds of 50 knots or greater, hail larger than 2 centimeters in diameter or just under an inch, or a tornado. In order for a thunderstorm to form, you have to have a moist, warm air, an unstable or conditionally stable air. And remember the lifting mechanisms from chapter 3. We're going to talk about that. I want to call it orthographic, where it runs up a mountain, an air mass or convection, where warm air rises into cold air, wedging at the leading edge of a front, and surface convergence. You're going to need to remember those too. This also be the result. Now, we don't see them here, but a dry line is where dry desert air pushes under moist air from the Gulf of Mexico. This is down in Texas. Thunderstorms have 3 basic stages. I'm going to hit this a light lick and then show you the picture. A developing stage, which is where you've got an updraft, and just an updraft, taking warm, moist air up above the freezing level, where precipitation begins to form. A mature cumulonimbus stage, where you have an updraft drawing in the warm, moist air, and a downdraft caused by falling rain or air that has lost its latent heat. dropping down to the surface. This creates a gust front and to have a roll cloud. I'm going to show you that in a minute. This is the most dangerous stage because you've got the highest winds. You'll have hail, lightning is forming. And then after 20 minutes of this, the downdrafts cut off the updrafts. With no warm, moist air, the storm literally runs out of gas. And it comes to an end and breaks up. The whole storm cycle lasts 15 to 30 minutes. And at the end of the storm, you'll get downbursts or possibly microbursts. And we'll go into that in a minute. And here's the picture that explains it. So the cumulus stage, you've seen a sky full of cumulus clouds, fair weather clouds, they call them, but that can be sneaky because if a cumulus gets really carried away, for like bad choice of words there, it will punch up through the atmosphere and start to rise. As it rises, the latent heat comes out of it, and that makes it rise faster. You get a mature stage where warm, moist air is rising up to 40,000 feet, and it flattens out or anvils, and then it starts raining. The rain drags down drafts with it. So you've got cool air dropping down to the ground. And then after a while, this downdraft cuts off the warm air at the bottom and the storm dissipates. Thunderstorms can be single, or they can also be in groups, a group of squall lines. Now this, or a mesoscale convective complex, which is a group of thunderstorms more or less in a circular or oval shape. And the outflow from a dissipating storms converges at ground level and assists the development of new storms, which is what keeps the squall line going. So a squall line may be associated with a front or dry line or jet stream divergence. It can be like 300 miles along the face of it, and but comparatively narrow, 50 or 100 miles wide at most. It can move along perpendicular to its length for up to 30 knots, have winds coming out of it of 60 knots, possibly forming tornadoes. I'm going to pause here. One thing that this article doesn't talk about is what's called a derecho. That is again, I'm being a little flippant. A derecho is a squall line on steroids. There's one or two a year in this country. They can travel up to 60, 80, 100 miles an hour. They could have winds coming out of them of 100 miles an hour. They are very destructive. I had Bob Allen send out to the group a article by a fellow who goes under Weather Box, who talked about a derecho that hit the Cleveland area in 1969. And he goes into how they form, and he talks a lot about what we've already discussed in this class. So if you haven't already looked at that, I urge you to go and take a look after I get done. We also have mesoscale convective complexes. These are oval or circular groups and not a line of thunderstorm. They can cover a large area and last for 12 hours or so. So you'll have several thunderstorms popping up in a condensed area. Now, this is what we were talking about. This is a cross-section of a squall line that is moving from left to right. The lead cell here is dispersing, breaking up. The warm, moist air that remains is coming down out of the storm, and it's almost immediately being drawn up into the cell right behind it. So this cell is feeding off of the cell that is coming to an end in front of it. And then this cell is dropping air down, and which is creating just the beginnings of yet another cell right behind it. So each of these cells only lasts half an hour, but they're following one right after the other, bang, bang, bang. So the squall line keeps going for several hours. Then we have supercells. This is a single thunderstorm, but it's much more long-lasting than most and much more powerful due to the presence of a large, stable mesocyclone. So this entire cell is rotating, aided by wind shear and an upper air inversion that caps off the convection. That ensures a continued inflow of warm, moist air. So this does not last only 20 minutes. This can last for hours. I once followed one of these things from Iowa all the way into Illinois over the course of 4 or 5 hours. It directs the flow of descending air to the front and rear of the storm so it doesn't cut off the updraft. 200 or 300 supercells in the US annually. And these are the mothers of tornadoes. So I have to confess, I'm not sure I believe this, but this is what the guys who know what they're talking about say. That you have air passing over and under an air mass. And because of these winds, it's hard to see. This is an arrow of wind blowing this direction and one blowing in the reverse direction. It's causing this entire mass of air here to rotate parallel to the ground. And then an updraft lifts that up and stands it on end, which creates a mesocyclone. I always thought that mesocyclones were created by, or supercells were created by converging air at ground level, going past each other and creating a rotating mass of air already vertical, but that's this is what they say happens. And here is a supercell. Now, we were talking before, well, let me get to it. You have warm, humid, moist air is being drawn in here from the front and also along the rear edge. It's being drawn into the storm and raised up. As it raises up, it loses its latent heat and begins creating clouds and rain, hail, and storms. And then you get the downdraft comes out the middle and blows out. And what you'll have is a gust front. So this wind is blowing out this way. This wind is blowing in this way. And so you have the roll cloud right in here with the warm, moist air on top and the downdraft underneath it. I don't know if anybody else experienced this, and I haven't experienced it much since I got out of high school. But it used to be when I was growing up that on these hot, humid nights, evenings, we'd have the warm winds blowing in and the sky would get dark. And then you'd get the gust of cold wind out of the thunderstorm. We'd run around the house opening all the windows and let the cool air blow through the house and cool it off. And then when it started to rain, we'd run around again and close all the windows. So the supercells are the ones that form the tornadoes too, because you've already got a rotation here and the rotation gets sharper and sharper and forms a tornado or a funnel cloud there. Now, downbursts come out of collapsing thunderstorms. The downburst is this column of descending air that spreads out at the ground due to the downdraft in the thunderstorm, in evaporating precipitation, which cools the air. So you've got cold air and being pulled by rain down out of the thunderstorm, slamming into the ground and fanning out. So it's dispersion at ground level. Microbursts are more dangerous. I don't know how many of you may have experienced microbursts.
I have.
Yeah. Okay.
Yeah.
A microburst,
especially a lot when I lived in Kansas.
oh yeah. I've experienced them there in northeast Illinois. They're very intense, wind as high as 100 knots, but only for an area of 2 or 3 miles at most. A lot of times even less than that. I've heard of microbursts that have hit just 2 or 3 city blocks. They have a lot more turbulence in them, a lot higher winds. These are the ones that knock the trees down. Now, lightning. This is the stuff that can kill you. 25 million lightning bolts a year in this country. They kill about 100 people a year, usually golfers. I shouldn't be flippant. They cause significant damage, including forest fires, house damage. There are 3 basic types. In cloud, cloud to cloud, that takes care of 80% of it. These are lightning bolts that are taking place up in the sky. Cloud to ground are the ones that are dangerous. Okay, one more sea story. I was staying at my daughter's house here 2 years ago, and a thunderstorm came through, and there was a hellacious crash, and it woke us up. And, you know, what the heck was that? Turns out that a lightning bolt had hit a tree 2 houses down from her house, traveled down the trunk, through the ground, into the wire for their invisible dog fence, followed that wire around into their garage and blew the control box off the garage wall. So what lightning is caused by? Charge separation. Negative charges in the cloud attract the positive charge on the ground. And this is the picture of it. You can't read this, and these pictures are not in the book, which is a bit of too bad. But you've got negative charges up in the cloud and positive charges at ground level. And as the winds in the cloud blow back and forth, it increases the amount of charge and the difference in charge between the ground and the cloud, till it gets to the point where little, what do they call them things? Excuse me, I got to lean in. It's called a stepped leader. Little trickles of electrons descending from the cloud and little trickles of positive charge coming up from the ground. And they kind of branch out and reach out to each other. And when they make contact, you get a pipe, and electrons by the trillions shoot through that pipe and heat it up into a superheated plasma. This allows more and more electrons to go through, which is why the lightning appears to flash in the same area. It's because you've got this conduit of heated air which conducts electricity, and more electricity shoots through it over and over and over again. Again, I've seen some pictures on YouTube of women with long hair standing on a relatively high point, and the hair rather, is streaming up from their heads, and they're laughing about it. And the thing is that is like charges in their hair is repelling the individual hair strands, because positive charges are forming up through them, and they're targets for lightning. So if something like that happens, you have to expect lightning. And one safety tip here: if you are in a place where lightning is possible, like out in a field or somewhere, the thing to do is to put your feet close together and crouch down to lower yourself, so you're much less likely to be a target. The reason for putting your feet together is that if lightning hits the ground, not even you, if it hits the ground a short distance away from you, the charge is dispersed through the ground. And if you're standing with your feet apart, it will go up one of your legs and down the other one with enough current to fibrillate your heart and cause you to have a heart attack. Okay, well, on that cheerful note, thunder, lightning, what happens is in that tube, the air gets superheated and it expands explosively. So it's creating a very small explosion that is very long and thin. So what you hear is the sound waves generated by this. So the part of the lightning stroke that's closest to you generates thunder that you hear immediately. And then from farther away on the stroke of lightning, you hear the explosive sound that's made farther and farther away, and it comes later and later, which is why a thunder sounds bang, boomity, 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 boom. The boomity boomities being from farther away in the lightning stroke. The low tones travel farther. Okay, now you're going to be questioned on this one too, is how far away is a stroke of lightning? You count, when you see the flash of lightning, you start to count. 1, 2, 3. For every 5 counts, the lightning stroke was a mile away. So if you count to 15 before you hear the thunder, the stroke of lightning was 3 miles away. Count to 20, it was 4 miles away, and so forth. So it's dividing the time it takes to hear the thunder after seeing the lightning by 5, tells you how far away it is in statute miles, approximately. And when you're dealing with lightning, approximately is close enough. Hail. Okay, hail is defined as solid precipitation larger than 1/4 inch. We had 1/4 inch hail here in Madison last week. It formed, I didn't save any. I'm not quite that crazy. It says hail is formed by repeated additions of ice crystals and supercooled water to a water droplet or a frozen piece of ice. Strong updrafts keep it suspended, so, and the longer it stays up in the cloud, the bigger it gets. It could have layers of soft ice or snow in it, and is alternating with layers of smooth ice. If you get a piece of hail that's big enough and can cut it in half, you'll see it's made up of rings, just like a tree. Under the right condition, hails can make several trips up and down within a thunderstorm, forming really large balls of hail, hailstones. Baseball size is not unheard of, softball size. Bob, I don't know if you remember, I want to say the biggest hailstone ever found was 17 inches. But
That's a big hailstone.
Say again?
That's a big hailstone.
It is a big hailstone. It's like South Dakota someplace. I'm dealing from memory too, so I might not have it right, but you get some really big ones occasionally. Okay, section 2, tornadoes. Everybody flash on Wizard of Oz. Okay, occurrence of tornadoes, how they form, the Fujita scale of damage, watches, warnings, and other types of vortices. Okay, what is a tornado besides scary as the dickens? It's a spinning column of air protruding from the bottom of a cumulonimbus clouds. Before they touch the ground, it's called a funnel cloud. It's usually conical shape, shape of a funnel. Usually they're cyclonic. That is, they rotate counterclockwise. Some are anticyclonic, which happens. You can also, a small one is can move forward at 25 knots or so. It moves at the speed of the cloud that it's descended from. It can be small, even smaller than 100 meters. winds of 85 knots, which is just a little over hurricane speed. The largest can move forward at up to 60 knots, be a half a mile in diameter, winds of 250 knots. I had to look it up. The one, I think it's still on record as the largest, is the Tri-State Tornado, March 18th, 1925. Now, 1925 was before there was any real good National Weather Service registering extreme weather. So nobody knew this thing was coming. And it was so big and there's so much rain around it, they couldn't see it coming. It started out in Missouri at 1 p.m. on the 18th. It dissipated at 4:30 p.m. in Indiana, 219 miles away. So it's traveling at upwards of 70 miles an hour horizontally. 695 people were killed. 2,000 were injured. It was a mile and a half wide. El Reno, Oklahoma, a few years ago had a really bad storm. I mentioned that only because I've been to El Reno, Oklahoma when I was working for the railroad. Moore, Oklahoma, southwest of Oklahoma City, had the highest wind speed recorded, over 300 miles an hour. So there have been a lot of tornadoes that have been very nasty. We had some, have had tornadoes already this year, something upwards of 100 of them, I believe. A lot of them in the Midwest, downstate Illinois, Missouri, downstate Indiana. How tornadoes form? Okay, a wind shear forms a rotating horizontal column. Once again, they're saying that if tornadoes and these mesocyclones are formed in a horizontal fashion and then get stood up on end. When stretched by an updraft, it narrows and spins faster. A wall cloud comes down from the supercell, and a funnel descends out of the supercell cloud. And when it touches the ground, it becomes a tornado. So that's what they're talking about there. And there is the wall cloud. So this up above is a supercell. This whole thing is rotating. It's rotating counterclockwise, and out the bottom back of that will descend a tornado. I don't know how many of you have discovered the storm chasers on YouTube channel. Some of them are pretty good and very interesting to listen to, and they describe how these storms are forming, and they combine their visual observations with radar imaging, which is quite educational. Okay, and that's what tornadoes look like. They'll form, these are very clear ones. A lot of times you can't see them because they'll be inside clouds or rain. They'll form like this, come down, they get a debris cloud at the bottom, they'll enlarge and eventually disperse. Now, a scientist, I forget his first name, I'm sorry to say, from University of Illinois, I believe, Fujita,
Glenn,
came up, say again,
Glenn.
Bob?
Glenn.
Glenn Fujita, thank you. He came up with a scale for the strength of tornadoes. And after they'd used that for a few years, they modified it and corrected it. And it became the enhanced Fujita scale. The thing to remember about this does not measure the size of the tornado, how long it lasts, what the wind speed is, usually because wind speed indicators don't survive a tornado going over them. This is based on the amount of damage that the tornado causes. And again, if you listen to these storm chasers, they sometimes get a little incensed by that because they'll have a very large, violent tornado that just passes over farm fields and doesn't damage anything, and it doesn't get a high EF score. So without going into details, EF0 is 55 to 75 miles an hour, which is not bad. EF5s, which are very rare, are above 175-mile-an-hour winds. The wind speed is estimated based on the damage, and the damage is what sets the EF number. You're going to hear about that too. Okay, a tornado watch. This means the conditions are right for the occurrence of a tornado, and they have gotten really good at this. Just in the last 10, 20 years, they've gotten much, much better at being able to call a watch. It'll cover a large area, several counties, half of a state, valid for 4 to 6 hours. And all that means is that the possibility for tornadoes forming is elevated, and people should be listening and staying alert. A warning means a tornado has been seen by eye or Doppler radar. It's really cool because the Doppler radar indicates by color which way the raindrops or debris is moving. And when you get like a red patch and a green patch right next to each other, that is a tornado. Because the raindrops on one side are moving away fast, and the raindrops on the other side are coming towards the radar fast. Okay, it covers a smaller area, maybe a county or a half of a county. They try to predict the path and tell you where it's going to be, but that is difficult to do because tornadoes will change direction. They can have multiple vortices. That's a favorite stunt is a person is watching a tornado and another tornado forms right behind them. And the warning is good only for about 30 to 60 minutes. And you really should seek shelter when you hear one of these things. Where to seek shelter? Not in a mobile home. You leave a mobile home or a car or any other flimsy shelter. You seek shelter in a secure inside room if it's a one-story structure or in a basement. Speaking as a structural engineer, possibly the best place is under the basement stairs because they're supported on both ends and they have good healthy stringers. Do not waste time opening the windows. That used to be an article of faith that the house was destroyed by the low pressure in the inside of a tornado. Doesn't happen. It's caused by flying debris and wind ripping the house apart. So don't dawdle. If you're in the open, get into a ditch or another depression. And again, speaking as a structural engineer and a guy who used to inspect bridges, do not take shelter under an overpass. One thing, the overpass itself is going to act like a wind tunnel and increase the speed of the any tornado winds that are blowing through it. For another, the only way that it's going to do you any good is if the bridge is constructed in such a way that it has a flat area where the bridge bearings are that you can get up into. And a lot of bridges that's blocked off. There's a wall at that point, or the bridge seats are up so high you can't get up into them. People have taken shelter between the beams on top of the bridge seat during a tornado, but the odds are against it. Don't do it. Get down into the ditch next to the bridge. If there's no other option, travel perpendicular to the direction of the tornado's movement. But good luck figuring out what that is, because just looking at a tornado, it's really hard to tell which way it's moving, and they can change direction. Okay, other types of vortices. These are much calmer. water spouts. Anybody ever see a water spout? All you Coast Guard people, you should have been out in the water. You should have seen. Maybe
Yeah, I've seen about
water
2
spouts.
on Lake Erie.
Oh, okay, good, yeah. I believe I saw one once on Lake Michigan. It's a sort of tornado that's moved out over the water, and because the water is partly because the water is chillier, it doesn't have the same energy input, so it's a lot milder. It's one kind is a tornado that has moved out over the water. The other is just a vortex that forms over water. In warm air over warm water, less than 55 knots, and there still can be dangerous to boaters. You get splashed with 55-knot winds. It's not going to be fun. Okay, Jock, you raised your hand. What did you want to ask?
I didn't want to ask, if you'll permit me to just make an observation. We've been
Please.
sailing near Washington National Airport, which is on, so the planes coming in would occasionally drop vortices onto the sailboats below because they're coming in quite low at that point. So I think it's probably similar to this water spout, and more of a curiosity than any real danger, but something specific to that location, and probably a few other ones. Thank you.
Yeah, come to think of it, I've been one the times I've hung out under the approach to O'Hare, and I have not seen so much, but I've heard this funny gusty noise, which would be a tip vortice or something coming off of the airplane. I would think it more comparable to a dust devil if it isn't sucking up in any water. But a gentle vortex in the air. So I never thought of airplanes. I'll remember that if I ever go sailing again under the approach to an airport. Okay, there's water spout, and a dust devil is sucks up dust. Again, it's a phenomenon caused by heat on the ground, hot air rising off of heated ground, and turning in a circle and getting tight and speeding up. Section 3, tropical storms and hurricanes. Okay. First, tropical cyclones. We're going to talk about them in contrast with extratropical cyclones. And then hurricanes, which are another step above the tropical cyclone. And how they are caused, why they cause damage, and what to do about them. And I'm going to take a short stop here. For those of you who are not familiar with it, this book, Isaac's Storm, A Man, a Time, and the Deadliest Hurricane in History. This book is one of Eric Larson's first books, and it talks about the Galveston hurricane of September 1900 and goes into how that formed and what it did to the town of Galveston. And it's a very good read, and alternates chapters about the weather and how the storm formed with the people who subsequently experienced the storm, including Isaac Klein, who was the weather bureau person at Galveston when the hurricane took place. But he's not the one that I like. Pardon me while I look up the guy's name. Okay, Theodore C. Born-Kessel. Oh, I'm sorry, wrong name. Okay. I'm looking for a man's name, excuse me. Yes, here we go. Dr. Samuel O. Young, the secretary for the Cotton Exchange in Galveston. And the reason I find him significant is that on the last days of August 1900, he went to the Cotton Exchange and looked at the weather map that was being prepared and at the winds and the temperatures and the cloud cover. And he looked at that and said, there's a hurricane in the Gulf of Mexico and it's coming this way. And he was the only one who predicted it. He was an amateur. Okay, moving right along. A tropical cyclone. These include tropical depressions, tropical storms, and hurricanes. A tropical cyclone differs from an extratropical cyclone. You all remember what those are. Those are the lows that we get up here in the Midwest. But the extratropicals have a warm core. Remember, we talked about the core in a cyclone and a low. They don't have a front attached to them, and they form in tropical waters.
The tropical cyclones have a warm core, right?
Yes. Did I say extratropical? I was reading the wrong one.
I think so.
Sorry. So the tropical cyclone has the warm core. This is the extratropical cyclone. You see, it has a front coming out of it, and it's revolving counterclockwise, and it's rather large, 700 to 1,000 miles, and it's in the Midwest or further north. The tropical cyclone does not have any fronts associated with it as a rule, and it revolves counterclockwise, and it's much smaller, only 200 to 500 miles. Okay, necessary conditions for formation: warm water. The South Atlantic, just above the ITSZ, converging surface winds. Sufficient Coriolis effects up to the 500 millibar level. Unstable air, high humidity. Again, it's over warm water, so the air is very humid, and not much wind shear. And an upper level divergence, lower level convergence. So air is flowing in the bottom, spiraling up, and coming out the top. Now, where these occur, this is a little surprising too. We all know about the Western Atlantic Ocean and the Cape Verde Island storms. Those are only amount to 12% of these these tropical cyclones. The Eastern Pacific gets 15%. The Western North Pacific gets 30%. So the tropical storms form in our area, they form in the Atlantic, and they come across, and they are steered by the Bermuda High. Sometimes they turn into hurricanes. A large Bermuda High guides hurricanes into the United States. A smaller Bermuda High lets them recurve in the Atlantic Ocean and go out to the northeast. The life cycle of a tropical storm or hurricane is an easterly wave or lifting mechanism allows a group of thunderstorms, which is just a tropical disturbance, to develop right off the coast of Africa. It's an easterly wave, an upper level wave in the trade winds, and it has no rotary motion. A small fraction of those become a tropical depression. They start to rotate. Winds are less than 34 knots, but it's a structured storm. When the wind exceeds 34 knots, it becomes a tropical storm, and it is given a name. Remember that. 34 knots and above, it gets named. I once heard that the reason they named hurricanes came from a novella that was written in 1948, where one of the characters was a meteorologist who named the storms out of a sense of romance, and the Weather Bureau thought it was a great idea. When winds exceed 64 knots or 75 miles an hour, it becomes a hurricane. And then if it hits colder water in the North Atlantic or over land, it dissipates sometimes. Okay, this is the structure of a hurricane. You have bands. It's made up of bands of thunderstorms that spiral around the center. These rain bands are typically 3 to 30 miles wide and 300 miles long. Warm, humid air is spiraling inward and then getting closer and closer to the center where it spirals up through the wall cloud. And then here's the part that surprises me is that once it gets up to the top, air is sinking 20 to 40 feet per minute in the center, in the eye, warming it and suppressing the clouds. The winds are mostly calm around there, which is why the eye is clear and calm, is because the air is descending right there. And as the storm moves 10 to 20 to 30 knots, it is pushing water in front of it. That's the storm surge. And if the storm surge corresponds to the high tide when the storm reaches land, then you've got real trouble. Okay, now hurricane categories are the same sort of thing in that it's the amount of damage that is done by the storm that judges off the category. So a category 1 storm, the pressure goes down to 980 millibars. The wind is up to 82 miles an hour. There's a 4 or 5 foot storm surge. Category 5 is a catastrophic hurricane. The pressure is down to 920 millibars. The wind can be over 135 miles an hour. 200 mile an hour winds are not unheard of. And the storm surge can be up to 18 feet. So you've got extensive flooding. Now, this is what the storm surge amounts to. Most damage is not from wind, but from the storm surge, flooding and the waves on top of it, which slam into structures and knock them down. So a 10-foot storm surge with a 2-foot tide will push water 12 feet above mean sea level, plus waves on top of that caused by winds of hundreds of miles an hour. The surge's worst effect is bringing storm-whipped waves far inland. The waves batter and cause more damage than high water alone. One more sea story. A few years back, my wife and I went to the Florida Keys, had a great time, stayed at this little motel down towards Marathon. And we drive to Key West and come back because it was a little cheaper. Then they had a hurricane come through there 2 years ago, I believe. And I looked on Google Street View, and that hotel had ceased to exist. There was nothing left. Okay, watches and warnings. A gale warning is issued when the winds are expected to be above 47 knots. A storm warning is when it's above 63 knots, up to 73 miles an hour.
Hey, go back to that. Try that gale warning one again. Go ahead.
Okay. Gale warnings are issued when winds are expected to be 34 to 47 knots or up to 54 miles an hour. What did I say?
I thought I heard over 47.
Okay.
That's what I heard too.
Up to 47. Oops. We weren't done with that page. There we go. Okay. Now then a storm warning is up to 63 knots or up to 73 miles an hour. Hurricane, after 73 miles an hour, it's a hurricane. A hurricane watch is issued for coastal areas when hurricane conditions are expected within the next 48 hours or for the next 48 hours. Warning is issued if any of those conditions are expected within 36 hours. You'd think that there'd be more difference than just 12 hours there, but you'd be wrong. So they expected winds over 74 miles an hour, high storm surge and waves, and then a flash flood warning is issued when flooding is likely. And of course, it doesn't have to be storm surge flooding. You can get several feet of rain, and if you don't get rid of that, you're going to have floods inland. Okay, so here's the summary.
Do we talk about latent heat there at the beginning part of the hurricanes? That's something that they really emphasize in the text.
I believe, yeah,
Go back.
I did not use the word latent heat, but I don't think it shows up in any of these slides anywhere. But yes, that's very important. That, of course, a hurricane is basically made up of a bunch of thunderstorms rotating in a big circle. And we all know that when you've got thunderstorms and air rising, you've got the release of latent heat. It's more in a hurricane because since they're formed over warm water, you've got a lot of latent heat trapped in the updrafts that the thunderstorms and so forth are pulling up into the storm. But yeah, that's going to show up. Thank you, Bob. Okay, so thunderstorms need moisture, unstable air, and a lifting force. There are 3 stages to a thunderstorm: developing, mature, and dissipating. Thunderstorms are in groups, either squall lines or mesoscale convective complexes, or by themselves. A supercell is a long-lasting single thunderstorm and the most dangerous. Downbursts and microbursts occur when thunderstorms dissipate, and they are dangerous to boats because they are sudden gusty winds. Lightning comes in 3 flavors: in cloud, cloud to cloud, and cloud to ground. Dividing the time from when you see the lightning to when you hear the thunder by 5 gives you the distance in statute miles. Hail is a solid lump of ice over a 1/4 inch in diameter. Under that, it's going to be sleet. Tornadoes. Okay, we didn't say this. Tornadoes occur in all 50 states at any time of year. Okay, a spinning column of air beneath a thunderstorm. They form out of a mesocyclone supercell. They're classified by the damage potential using the enhanced Fujita scale. A tornado watch is issued when the conditions are right for the formation of severe thunderstorms and tornadoes. A warning is issued when a tornado's actually been spotted, either by a observer or on radar. Tropical cyclones are storms that form in warm tropical waters. They need moisture, instability, lifting, steady winds, and an upper high. They occur in the Atlantic, Pacific, and Indian Oceans, and the storm surge and waves do most of the damage. Okay. Bob, you want me to do these questions and then you'll take the other ones?
Sure, that sounds fair.
That's
All right. Are you all ready?
Okay, everybody sharpen your pencils.
Uh-huh.
Okay. Jack Woodsley. There you are, Jack. Can you tell me the life cycle of a thunderstorm? What 3 stages there are?
Sure. It's like a good party. Developing, I think they call it mature and dissipating.
You got it in 3, yep. Okay, Jack Benton. What's a squall line? Why does a squall line last so long? Are you there, Jack?
Okay, squall lines are long lasting because each cell feeds another cell and another cell with the downdrafts and then the updrafts.
Yep, the dissipating cell causes convergence, which is essentially what you said there. Okay, let's see. Find some more people. Pat, are you up for telling me why isolated thunderstorms during the afternoon and early evening are probably of what type?
Air mass thunderstorms.
Air mass thunderstorms, right. And Jennifer, a downburst and a microburst are associated with what? Here to hazard a guess?
Sorry, I was muted. Wind speeds.
Mature thunderstorms, actually. Okay,
Sure. Okay.
actually, yeah, the dissipating thunderstorms usually that you've got this big column of air up there full of rain, very heavy, and then when the updraft sort of collapses, the whole thing falls down and causes a big downdraft, which smashes into the ground and spreads out.
Excellent. Thanks.
Good night.
Okay, so, all right, Bill Madsen, how's your math skills? You hear a thunder 20 seconds after seeing the lightning. How far away is the lightning stroke or the storm?
4 miles.
4 statute miles is correct. And that, which is another thing to be mentioned. You may think that the thunderstorm is 4 miles away, but lightning has been known to travel horizontally and show up far ahead or far behind the actual thunderstorm. Okay, who we got? Tony Policandri. Did I pronounce that right? Tornadoes have been observed where and when? Say again, Tony?
I was just joking that you butchered my name, but that's okay.
Sorry about that.
All right.
Well, you can make up for it by telling me where tornadoes have been observed.
I'm going to pass on that, please.
All righty. Who next? John Zills? All 50 states and all months of the year. Who said that?
Richard Clements.
Hi, Richard. Thank you. Okay. Let's see. John Zills, can you tell me where the most intense and damaging tornadoes are associated with?
Supercell.
That's true. Actually, I think all tornadoes are associated with supercells, but this is the way they phrase the question. Okay. Jeff Link or Jack, you want to try the enhanced Fujita scale for tornadoes? What's it based on?
Sorry, are you, I'll take that. It's Jock, J-O-C-K, Jock Whittlesey.
Oh, okay.
Based on damage.
Damage, indeed. The amount of destruction. Like I said, that seems like a really silly way of doing it, but there isn't a better one. Okay. Jeff Link, the path of a Cape Verde hurricane is affected by upper level winds and it's a thing.
If I'm not mistaken, they're impacted ultimately by the rotation of the Bermuda High.
It is the Bermuda High. If it's small, they miss the US. If it's big, we catch it. I think this is the last one. Chris McNamara, the principal source of energy required to maintain a hurricane is? No, this isn't the last one.
Light and heat.
Latent heat, that's, yeah, that's why Bob took me back and asked me to do that one. Okay, 5 more. Okay, Danny Mullen, the relatively clear air in the eye of a hurricane is due to what?
The wind's going down.
Descending air, yeah. When I was growing up, they always said that the air was going up in the eye, and that's why it was clear there. Okay, so Don Uzniak, the strongest winds in a hurricane are?
In the eye wall.
In the eye wall, indeed. And a salute to the crazy people who fly research aircraft into hurricanes. Okay, the 5 categories of the strength of a hurricane are based on Joe Jackson.
No, I'm gonna pass on that one.
Okay, Richard Clements.
Let the wind speed.
Right. Actually, the central pressure, wind speed, and storm surge height, all 3. Okay, the National Weather Service considers a hurricane a major hurricane for what categories? And I didn't say this, so I'll apologize. It's 3 and above. It's in the book, but I didn't tell you about it. Okay, which warning is for stronger winds, a gale warning or a storm warning? Steve Boyer. Is a gale warning or a storm warning worse?
His microphone.
I think it's the storm warnings.
And I think you're right. Very good. Okay. Lee, yeah, that's the end of those questions. Okay. So Bob Allen is going to go and talk about, ask the questions of everybody else. Thank you for your attention. Does anybody have any other questions that I can answer?
Chaz, there was a question earlier regarding wind shear. Who asked the question again? I'm sorry, I forget. What was the question about wind shear? You want to click back about 20 slides to find the wind shear one?
That was me, Jock, who asked that question. I just want to kind of have you walk us through that. You mentioned, for example, that it was a component of thunderstorms, and I'm just not sure I can differentiate wind shear from, you know, downbursts or something. Could you kind of sort all that out for us? Thank you.
I'm not sure I can either. Okay, so let's see.
If you want to go up to the one where it was sort of like a slinky on the ground, that might, hey, you could use that one.
That one, yeah. There it is. Whoop. Okay, yeah. So what they're saying here is that you have like upper level winds are moving in one direction like this, and at lower down they're moving at an angle, maybe not 90 degrees, but a different direction than the upper level winds. And this air, one parcel of air moving over the other parcel of air creates a zone in between where the air is actually rotating horizontally, like a spring rolling along the ground. And then it you get an updraft, lifts this coil of spinning air vertically and turns it into a mesocyclone. And I don't know, Bob, I don't know if you agree with me or not on this. I have trouble imagining that happening.
So what you're thinking of here is, remember, at high altitude, when it says high above the ground, they're talking about up in the jet stream or the higher altitudes. So does that help at all?
Yeah, somewhat. I'm still thinking in terms of converging air at ground level or just above ground level. And as it converges from different directions, it sort of goes past each other and then begins rotating around each other, partly due to Coriolis and partly due just to going past each other and creating a vertically turning column of air. So the air is converging and then going upwards. And as it's lifted, due to the way the winds are entering it, it becomes a cyclone. I can visualize that happening, but I don't want to mislead people. This is just what I think goes on.
So
the guys who wrote this, who know what they're talking about, say that you've got upper level air on, what is that, like 5,000 feet and 15,000 feet passing over each other, causing a circular circulation.
So the 300 millibar level, you're talking about the jet stream. You're talking about 30,000 feet.
Okay.
And the surface level winds, let's say the winds are out of the south over Chicago's like number 2. You pretend Chicago's at the tip of the arrow number 2 there. And up at higher altitudes, you got the prevailing westerlies coming out of the west. Well, those two winds don't agree. So what you can have here is, and it's not really easy to visualize, but you see the first circle on the left? Imagine it's actually moving as it's being pushed by the jet stream, which is number 1 there, from your left to your right. So it's not really a perfect cylinder, it's more of a spiral. Does that make any sense? Does that make it a little clearer? So it's, you know, like it's like a slinky on your stairs, where it's got that
Or spring.
spring is another way to put it, yeah.
Chaz, this is Jack. They talk about that on page 64. It's downburst and microburst coming down the sides of the big cell, and when it hits the ground, it shoots out in all directions, and that's what they consider the shears.
Yeah, and the book focuses on the mature stage of a thunderstorm, not necessarily
Right.
dissipating stage.
Yeah.
So there's still plenty of energy in a mature thunderstorm to give you those conditions. Not just a dissipating stage.
Condition you don't want to have when you're landing.
Good. And it's tricky stuff to visualize.
There's a better picture in the book showing how the downburst goes, I think.
Good.
Yeah, I don't think we have the slide that you just put up there. It's not in the material that we have, at least not the material that I have.
Which one you talk about, Oliver?
The one that you've been talking about, the mesocyclone. Let's say back, yeah, that formation. I don't see that in. I don't see that in material.
No.
Maybe I'm missing.
No, it is. This is only in the PowerPoint deck. It isn't in the book.
But I also noticed that the other slide that showed the eye of the tornado, it's here in our material, but it doesn't quite look like the slide that this is page 69. It doesn't quite look like the slide that you have here.
Yeah, now Jennifer says she is looking at page 63, and it has a similar idea with the horizontal tube and its life there.
Hey, Bob, I got a question about the last slide with the slinky. It looks like, and this may be just a graphic, are the winds actually rotating in opposite directions on either side of the updraft, or is that just a graphical misinterpretation?
Well, go ahead, Chaz.
Oh, I think I know.
On the bottom, on the lower one.
Okay. The winds are rotating like this.
Yeah.
The arrow is on the side closest to you. Yeah,
Right,
it's,
so then you look at
it
the
is
bottom.
hard to tell from that picture, but because the upper level winds are blowing from the back of the picture towards us. So this rotation has got to be coming over the top towards us.
Yeah, it's hard to visualize in 3 dimensions, but if you look at the 1, pretend the 2 wasn't even there. It's sort of spinning the air on top around. But like I said, it's more of a spiral shape. You know, and I looked at this graphics a couple times before I realized what they're trying to show, which is what Chaz was saying. It's sort of got it's like a tube, right? Who's got a good tube I can use? But it's like rotating a tube of air.
Right.
Where are you going, Chaz?
It just looks like the photo.
I'm trying to find the book pictures.
But if you look at the circles on the bottom of the start of it and the right and left, they're in different directions. The bottom circle on the green.
Right.
The one on the left is
Yeah, it is. With this graphic, it's really hard to tell which part of the circle is closer to you and which one's farther away. This is a tricky one. And if you look at the 1 there and imagine that it's pushing the arrows towards you and down, not the other way around. It's not going away from you, it's going towards you. This graphic, this is a tricky one. I'm not crazy about it. The graphic, that is, because it's pretty hard to deduce what direction those arrows are going. It almost looks like they're going away from you, but what they're trying to show is just like, imagine, you know, the wind was blowing it over the top of this, and as it does, it rotates it. Does that make any sense?
Yes.
It just kind of turns it as it's coming at you there. So, but it's really hard to tell from the way this graphic is whether or not it's coming towards you or going away from you, but it is coming towards you.
I figured it out. It's like a slinky. The one direction, but once you got to the top and go back, it's the bottom seems like it's turning in the opposite direction.
Yeah, good question. That was a good question, Jock. Other questions? Chaz, did you have something else you wanted to get into before we get into the review questions?
No, I was looking actually I got here into the book materials and I was looking for that other picture and I'm not finding it. So
You want to dig around for that while I go over to everybody? You want to stop sharing for a sec? Go ahead and hit stop share.
okay.
All right,
I
team,
gotta
ready for
get
the
back
quiz?
into Zoom here.
Towards the bottom, it says share screen.
Stop share, there it is. Okay.
You guys can turn your cameras on if you want. I'm just going to go through everybody. Pat, how about number 1? The life cycle of a thunderstorm has stages.
B, cumulus, mature, and dissipating.
Good. And they repeat that a couple times just to kind of hammer it home. Jock, number 2, the first stage of a thunderstorm cell has. Unmute, Jock.
Sorry, updrafts.
Correct. Ed, how about you for number 3? The mature stage of a thunderstorm cell has. You there, Ed?
Updrafts and downdrafts.
Good. They hit pretty hard on this, so you know you might going to see it again if you hear me talking there. Number 4, Jennifer, the dissipating stage of a thunderstorm has.
Dissipating stage of a thunderstorm has cold downdrafts.
Excellent. Bill Madison, number 5, squall lines are long lasting because.
The downburst in existing cells cause others to develop.
Good. It's like a pandemic. Tony, how about number 6? The distinguishing characteristics of a supercell is.
It contains a large rotating mesocyclone.
Good. John Zills, number 7, the condition or conditions that favor the development of thunderstorms is.
All of the above.
All of the above. Yeah, if it's R, it's got to be more than one. That kind of gives away the answer. You got to be smart when you take these tests, guys. It tells you the answer half the time. Jack Benton, how about number 8? Individual thunderstorms on a hot afternoon are most likely.
That's air mass.
Air mass, right on. Jeff Link, as a thunderstorm approaches, the wind is likely to be.
That would be B, first toward the cloud, and then you feel it coming from it.
Absolutely. Chris McNamara, number 10, downbursts and microbursts are associated with.
Had to unmute. Cumulonimbus clouds.
Yeah, it's not going to be wimpy little towering cumulus. They're pretty, but until they start to get exciting, it's not going to be the main event. Don Osiniak, number 11, microbursts are more dangerous than ordinary downbursts because of their
B, small size, high winds, and sudden onset.
right on. Yeah, C is wrong. Relatively long life. They're not expected to last very long. So that was a hint on that one. Joe Jackson, 12. The estimated distance to a thunderstorm, if you hear the thunder 20 seconds after you see the lightning, is?
C, 4 statute miles.
Yeah, remember this answer is going to be in statute miles and divide by 5. Right on, Joe. Richard, 13. Tornadoes are?
C.
Good. Yeah. C is the correct answer. I'm not going to say the other answer because it just confuses you. Stephen Boyer, 14. Tornadoes have been observed in?
Well, it's supposed to be in all 50 states, but I can't believe they got them in Alaska.
They've had them. Yeah, they've had them there. That's why it's a fun question. Probably
Really?
not
All
that
right.
many, right?
Yeah, that's good.
Maybe an ice tornado. No, it's not an ice tornado.
Yeah.
They've had them in all 50 states. Good answer. Bob Mack, how about number 15? Tornadoes are known for their?
That would be high winds.
Yep, right on. Oliver, number 16, the most intense tornadoes are associated with?
Supercells.
What was that?
Supercells.
Yeah, I was very tempted by C on that quiz because C is a close answer, but no, they're looking for B. So remember that when you take the test. JT, I can't remember if your microphone works or not. 17, the enhanced Fujita scale for tornadoes is based on? Can you answer, Joy, or no? I can't remember her microphone works. You there, JT? James Zimmerman, what is 17? 17, James. The enhanced
That depends
Fujita scale for tornadoes is based on?
The amount of destruction.
How trashy. Yeah, good. Addison, 18. Non-tornado water spouts.
Like every federal test I've ever taken, all of the above.
All of the above, right? Jean Pagan, number 19. The intertropical convergence zone. We didn't hit this too hard, but this is a fascinating topic. We talked about it earlier. You notice how it says the last one, the correct answer could be found in pages 10 or 11. So I guess it's seeing if it remember. I'm sorry. Go ahead, John. Gene, can you talk? I don't know if you can. Gene V. Monique, did you say you didn't want to have any quiz questions? I'm trying to remember. Somebody told me they didn't like quiz questions.
No, it's okay. It's number 19.
19, yes, please.
All of the above.
Another all the above. You know, who was it? James that said like all those government tests a lot of time. No, how about number 20, the Bermuda High?
B, affects the tracks of Atlantic hurricanes.
Yeah, now Chaz did a nice job explaining this. In wintertime, it's small. As it gets warmer and warmer, that rotation around that Bermuda High gets bigger and bigger, and that's what pushes those hurricanes into the US of A.
So,
Bill
so
Luxor-
Bob, just a quick follow-up question. The Bermuda High is pretty much always there. It just varies in size by season.
Right. Yeah. Out on the middle of the ocean, it's can be relatively small, but as that southern Atlantic water heats up, it expands. The high pressure expands, which causes a larger circle, bigger and bigger circle. So that's going to push those hurricanes farther to the west, which means instead of just scooting off east of Florida and going north, they might go into Florida or even into the Gulf. So
Okay, thank you.
made sense here.
Alexia,
What's that?
you called my name?
Bill, yeah, how about in the next one? Where were we? I'm sorry, forgive me.
21.
21. Compared to extratropical cyclones, hurricanes are?
A alpha, smaller and more intense.
Good. Yeah, Chaz did a nice job explaining that. We're going to start over again. Pat, the principal source of energy required to maintain a hurricane is?
Latent heat.
Correct. Is there anybody I've not called on that wanted to be answering a question? I don't want to skip anybody. Jock, number 23, a tropical cyclone is given a name when?
when it has winds of 39 miles an hour or more.
Good. And this is one you're going to have to memorize the correct answer for this one. I guess for this particular answer, it just tells you it's based on wind speed, but knowing that that 34 knots or more is critical. Ed Hallen, how about 24? The eye of a hurricane is an area of
Descending air.
right on. Jennifer, 25. The strongest winds in a hurricane are located
In the eye wall.
Yeah, watching those C-130s fly through there. That's wild and crazy stuff. Bill
Mhm.
Madison, 26. The relatively clear area of the eye results from,
Descending air, A.
yeah, as it sinks, it clears out. Tony, 27. After heading north, an Atlantic hurricane turns northeast due to,
The Bravo, the circulation of the Bermuda High.
right on. Yeah, Chaz explained this wonderfully. John Zels, 28. The National Weather Service calls a hurricane major if it is,
A category 3 or above.
good. Jack Benton, 29. A hurricane watch is issued
If conditions are expected within 48 hours.
yeah. And Jeff Link, back to the last one, number 30. A hurricane warning means,
That would be hurricane conditions expected within 36 hours.
yeah. So just
B.
kick, good, right on, Jeff. So kick around those numbers. Warning, a day and a half. Watch, 2 days. So you got some early warning. Now, when Ian nailed Florida this last time, there was some talk about it, but I didn't really take it that serious until it really, started doing some destruction. Evito said he's going to be here later. Good. Other questions? Jeff, did you have another question?
Nope, I'm good.
Good. Any other questions? Yeah, we're getting down to, go ahead, Jock.
This is more curiosity than anything that really is important, but you guys were talking about the sort of spiral bands in a hurricane. Are those kind of like a breakfast pastry where it just winds around and gets smaller and smaller towards the center, or is it like a series of concentric circles? Any idea on that one?
Well,
Thank you.
it's a fascinating thing, a hurricane, because it has arms, and each one of those arms is powering the circulation in the middle by the release of that latent heat. So it's sort of like an old-fashioned steam locomotive, and with well, that's not a good explanation. What was the name of that original steam engine designer that had the thing spinning around and around? But as it spins, it's releasing steam in the opposite direction. So what is it?
Like a turbine?
What's that?
Like a turbine?
Yeah, like a turbine. I'm trying to think of the most basic steam engine ever invented.
Oh, yeah. Hero of Alexandria with the little jets in the ball.
Yeah, that's it. Yeah. So
okay.
Go ahead.
I think Jock's question is best answered that it would be kind of like a galaxy where you've got these spirals coming out. So you've got multiple arms that are up to 300 miles long, rather than a cinnamon roll, which has one spiral going all the way out. You've got like several of them. So it's kind of like a cinnamon roll, but not nearly as sweet.
The galaxy analogy is a good one. Thank you. That's perfect. Thank you.
We're all going to want cinnamon rolls in the morning for breakfast now. Look what you did, John. All right.
I just wanted to ask who remembers what the and I've lost it now. Excuse me, I got to find the study questions for 6. I clicked on the wrong thing and it went wooz. There we go. Hang on just one tiny jiffy. Okay. Yep. Okay, there we go. Okay, I just wondered how many people remembered what a lapse rate was.
I would love a
I had to look it
refresher
up.
on that too. Thank you.
Yeah, a lot of people had questions about how does lapse rate work? Well, as you climb higher in the atmosphere, the air cools. So as you get higher away from the ground, there's less density and the temperature decreases in the standard lapse rate. So as you're raising, you will have a basic number. Now that it shows it as a perfect line, an exact number, different parts of the atmosphere actually have different temperatures. So it may or may not be this perfect, angle as you increase, but it tells you we have 3.5. You're talking about the wet adiabatic rate, and what was the other one? 5 per thousand.
Yeah, 5.
Yeah.
So
1,000
it's basically how much temperature you lose per change in altitude.
Yes.
And you can.
And I had to look it up.
So let's say at the surface, the temperature is 70 degrees and the dew point is 50. So as you climb, it's 5 degrees per 1,000 feet. You divide 20 by 5, and that tells you that as the air climbs 2,000 feet, the temperature is going to cool off 20 degrees, so that instead of being 70, it'll be 50. So the temperature and the dew point will be the same, and that's where you're going to have the cloud base. So fascinating stuff. Good. And we have any other questions? Are there any other questions for this evening before we kind of wind things down? Go ahead, Jock.
Sorry, I seem to be talking a lot tonight, but I can't let people go without them knowing that I once experienced thunder snow. Thank you.
Cool stuff. Yeah, you know what was it Chaz was saying? He was walking on a steel boat and it was the middle of a thunderstorm. That's not a great idea, Chaz. You gotta be more careful.
No, it wasn't. I wouldn't have done it if I hadn't been so hungry.
Good stuff. We have, that being said, we have one more week. Chapter 8 is a shorter chapter, and I thought, let's just wipe out the entire class in one session. So on the 16th, it's a week from tonight, you're going to get double barrel action. It's a double header. It's a AUX weather double play. We're going to have chapter 7 and chapter 8. I'm going to go ahead and stop the recording. Blah, 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 blah.